All right, so next we're going to look at the being able to state what is the exact value of the sine, cosine, and tangent of 30 degrees, 60 degrees, and then after that, 45 degrees. Now, if you want to be able to determine what is the exact value of the sine, cosine, and tangent of 60 and 30 degrees, if I wanted to do that, I would start by drawing an equilateral triangle of sides 2 units. That's what you're seeing there, an equilateral triangle of sides 2 units. Now, a line drawn from the apex of an equilateral triangle and also an isosceles triangle to the middle of the base, a line from the apex to the middle of the base. So it's the middle of the base, so it cuts the base into 2 equal halves. So now over this side is 1 unit and this side is 1 unit. So a line drawn from the apex of an equilateral triangle or an isosceles triangle to the middle of the base is called the height or the altitude of the triangle. Now, the altitude bisects the angle at the apex. So first of all of these angles, interior angles, would have been 60 degrees because it's an equilateral triangle. So this would be 60 degrees. But then, and the top one would also be 60 degrees. But the altitude bisects the angle at the apex. So if it bisects it, this becomes what? 30 degrees. This becomes 30 degrees. And the height or altitude meets the base at what? Right angle. So in effect, the height or the altitude bisects your isosceles triangle into 2 identical right angle triangle. All right, so this is the height. Let's call it x. Let's find out what x is using Pythagoras theorem. So Pythagoras theorem says the square of the hypotenuse is equal to the sum of the square of the other 2 sides. The hypotenuse is 2, so it's 2 square is equal to 1 square plus x squared. This is 4 is equal to 1 plus x squared. So x squared is equal to 4 minus 1, which is 3. The opposite of square is square root. So x, the height of the triangle, would be the square root of 3. So this length here is the square root of 3. Let's change this color ink. Now let's start looking at 30 degrees. The sine of 30 degrees, the cosine of 30 degrees, and the tangent of 30 degrees. Then we look at the sine of 60 degrees, the cosine of 60 degrees, and the tangent of 60 degrees. Now watch me. Starting with 30 degrees, looking at this right angle triangle here, looking at that right angle triangle, looking at that right angle triangle there, we can see the side opposite to 30 is 1. The hypotenuse, which is in front of the right angle, is the hypotenuse is 2, and the side that is adjacent to the 30 degrees, ADJ, is root 3. Sine is opposite. Sine is opposite over hypotenuse. So it's opposite 1 over hypotenuse 2. The sine of 30 degrees is a half. Cosine is adjacent over hypotenuse. The adjacent is root 3. The hypotenuse is 2. The cosine of 30 degrees is root 3 over 2. Now, lastly, tangent. Tangent is opposite over adjacent. So that would be opposite 1. The side opposite to 30 degrees is 1. And the adjacent side is root 3. So it's 1 over root 3 or root 3 over 3. If you rationalize it, you'll get root 3 over 3. Next, let's look at 60 degrees. Let's change this thing to blue, the pen into blue. The side in front of 60 degrees is the side that is opposite to the 60 degrees. So the root 3 is opposite to the 60 degrees, but it's adjacent to the 30 degrees. 2 still remain the hypotenuse. And 1 would be the sine that is adjacent. Sine is opposite over adjacent. So that is opposite root 3 over the hypotenuse, which is 2. The cosine is adjacent 1 over the hypotenuse, which is 2. And the tangent of 60, tangent is opposite root 3 over adjacent 1, or just root 3. So if I wanted to know what is the sine, cosine, or tangent of 30 or 60 degrees, if I want to say what the exact value is, this is the process I would go through. Now, you need to be able to have this diagram in your mind's eye if necessary. So if someone asks you what the sine or cosine or tangent of 30 degrees or 60 degrees is, you need to bring up this diagram in your mind and then be able to say what the value is. Moving on. If I wanted to know what the sine, cosine, or tangent is of 45 degrees, I would start off with an isosceles right angle triangle. So an isosceles right angle triangle, these two sides are equal. And I would let both of them be equal to 1. By Pythagoras theorem, this side would be equal to root 2. Now, it's an isosceles triangle, so these two angles are equal, and they are both equal to 45 degrees. So if I wish to know what is the exact value of the sine, cosine, or tangent of 45 degrees, I would start off with an isosceles right angle triangle where the two equal sides are of length 1 unit, and the third side is opposite to the right angle. It's the hypotenuse, and by Pythagoras theorem, that side would be the root of 2. Use any one of the 45 degrees, it doesn't matter. The side that's marked 1 is opposite. The side that is marked 1 is also adjacent. And the hypotenuse is root 2. So we have the sine of 45 degrees, the cosine of 45 degrees, the tangent of 45 degrees. Sine is opposite over hypotenuse, so it's 1 over root 2, or root 2 over 2. the cosine of 45 degrees is also 1 over root 2, or root 2 over 2. So the sine and cosine of 45 degrees is the same. The tangent of 45 is opposite 1 over adjacent 1. The tangent of 45 degrees is 1. So you need to be able to say what the sine, cosine, and tangent of 30 degrees, 60 degrees, and 45 degrees is the exact value without needing to use a calculator.